gang, welcome back. So this week you are going to be studying evolution and just laying the groundwork for the next couple of weeks. So evolution is a biological theory, but to establish what a theory is, we want to make sure that you understand that in biology or in any science, when we say something is a theory, we mean that it's supported by boatloads of evidence. Okay, so a theory, another theory might be something like gravity, right? Gravity is a theory. If I were to drop this marker, we know it's going to fall every single time, right? It's never going to not fall in our mental context of how gravity works. And so evolution is much the same. Lots of support for it. And because there's so much support for it, we call it a theory. So we want to be careful that, my hair looks crazy, guys. I want to be careful that we understand that the way we use theory in science is not the same way we use theory in everyday speech and language. So evolution is a theory, and it is a theory that says that organisms have changed over time. That's the definition of evolution, is change over time. And so as the earth has changed over time, so too have the organisms that live here, or they've died as a result of not being best adapted to their environment. So there's several pieces of evidence we use to support the idea of evolution. In my Bio 111 class, if you're a Bio 111 student, you are reading chapter 16 along with this. And so just briefly, what 16 talks about that's very similar to what we talk about in any class is that evolution is supported by the fossil record. So the fossil record is all fossils that have ever been discovered over time. And so some of the most interesting fossils to me are the whales. And so if you are a Bio 111 person, your book talks about the whales a little bit. But here's the mystery of the whales. You guys, whales are mammals. And what we know about mammals is that they give live birth, they nurse their young, they breathe oxygen, but whales live in the ocean. So they're giving birth to live young underwater, nursing them underwater, and having to come up to the surface to breathe. Why? Like, how does that make any sense in the whole world? And so the interesting thing about whales is when you kind of dig into their evolution, you see that the changes in their bodies over time based on the fossil evidence is that they were probably more like a hyena, kind of like a dog-like animal, but with hooves. And we know, we think they have hooves based on the fossil evidence that exists at the same time as when they were kind of moving back toward the ocean. Lots of evidence for this, but your book talks about specifically Rhodocetus and Durodon as two of the ancient organisms that led up to whales being what they are today. Weirdly, whales have a hip bone, and they have a little, so a hip bone like you do. Well, what kind of organisms have hip bones? Animals that walk, right? Like that use their back legs to walk, and whales don't do that. And so why would whales have a hip bone? And that's really what caused people to sort of dig in and be like, wait a second. There was already something weird about whales living in the ocean and breathing air, but now add to it, they've got a hip bone, they've got a femur, which is this upper bone in your leg, right? They've got a femur, they've got a tibia and a fibula. Like, weird, why do they have these things? And so digging in, we find out that they have ancient ancestors that lived on land. And so I think that relates really well to what I'm asking you guys to do this week, which is to read the chapter 16, but then watch the video called Your Inner Fish. And I love this video because it so clearly exemplifies all the things that I want you to learn and understand that lead up to us believing that evolution is a theory that supports how organisms change through natural selection. And we'll look at all that next week. We'll look at natural selection next week. But evolution is supported by fossil evidence. That's one piece of evidence. A second piece of evidence is, I'm looking down at my notes, homologous structures. Your book talks about them as comparative morphology. If you've ever had a class where you dissect an organism like a frog or a fetal pig, or I've taught classes where we did sharks and perch and starfish and clams, all kinds of things. And the idea of comparative morphology is to be able to see how organisms have changed over time and what adaptations are new to some organisms or built upon by the organisms that are maybe a little more complex than them. And so that's comparative anatomy when you're doing those dissections. And comparative morphology just talks about how some organisms have similar structures and maybe they came from the same line of descent. So sometimes it's called homologous structures because homo means same, and sometimes it's called comparative morphology. Those two mean the same thing. Within that are the vestigial structures, which is pretty cool. So vestigial structures are structures that no longer serve a useful function. So can you move your ears? Like, I don't think you can see mine moving. My glasses move when I do it. I can move my ears. I have the muscle capacity to do it, but not the reason for needing to do it anymore, right? Like I'm not hunted in the woods and need to like turn my ears around and listen for predators. So the capacity remains. I still have the muscles that do it. I still have the neurology that tells me how to do it, but I don't need to do it. I don't have a function for doing it anymore. And so we're starting to really lose that capacity. In the same vein, humans are losing the space in their mouths for their wisdom teeth, right? So that last set of molars that come in, we are losing the ability to grow those in because our jaws are getting smaller and smaller. We truly do not chew as much like raw food or raw meat as our ancestors did, right? So we don't need as many molars. Now, it's not a function of like, oh, I don't need it, let me get rid of it. But why would the body continue making something that is not useful? And that's how evolution sort of works. If it's no longer useful, I'm not going to expend energy making it. So if my body has the capacity to not do that, it will stop doing that. Over like thousands of years, right? Thousands or millions of years that happens. I keep seeing my light reflected in my glasses. I'm going to move those. Okay, so vestigial structures. There are lots of other vestigial structures. Your book hits on some of them. There are videos out there that talk about other ones, but those are a couple of my favorites. Your tailbone is one too. So we don't have tails anymore, right? There's more. We won't go into all of them. Another one talks about biogeography. Bio means life. Geography is talking about the distribution of where organisms live on the earth. And how on different continents, even though we were all one continent once, right? Pangea, we were all one big continent once. And then the organisms were separated when the continents separated, right? And so as they drifted apart over many years, those organisms changed due to probably their environment, maybe where they were living or the food they were able to access or some other factors there, right? And so the organisms still look similar to each other. For example, we have muskrat that live in our pond. You know what a muskrat is? It's a rodent. It is it's like a beaver, but without the big cool beaver tail or like the teeth. It's just a rodent. So muskrats, beavers, and capybara. If you haven't seen a capybara, look it up. Oh my gosh, the largest rodent in existence, and it's in South America is where it's commonly found. It's humongous. It's like the size of a Great Dane, right? So it's a really big rodent, and it reminds me of The Princess Bride with the rodents of unusual size. If you haven't seen it, see it, watch it. That's your other assignment for this week. Watch ridiculous movies that make you laugh. So this week you are going to be learning more about the supports for evolution besides what I just said to you. You're also going to watch my favorite video that relates to this. It's a actual like documentary. It's called Your Inner Fish with Neil Shubin. So Neil Shubin actually has followed that up with Your Inner Primate and Your Inner something else. I can't remember what the other two are, but he has two more in that documentary series. If you love Your Inner Fish, feel free to watch the others. I'm not assigning those. But when you summarize Your Inner Fish for me, make sure you're just summarizing Your Inner Fish, even if you watch the other ones. Feel free to tell us about the other ones as well, but your assignment is about your inner fish. And it's going to walk you through fossil evidence. It's going to walk you through homologous and vestigial structures. It's going to talk about embryology, so the comparison of embryos and how they are similar and different from one another across many species, including fish and humans and many others. That one, the concept of embryology really falls under homologous structures as well. Sometimes we put it as a separate topic, but also it is about homologous structures as they're developing in utero, for humans anyway. Okay, so this week, an introduction to evolution. Next week, we will look at natural selection, and the following week, we'll look at other ways that organisms evolve besides natural selection. So there are other ways too. Okay, I think that's it for now. As always, if you have any questions, reach out, and I'm happy to discuss them with you.